Hello everyone, welcome back to my channel. Maths is fun. So today I will be discussing the chapter of circles of class 10 ICSE and CBSE. So in circles there are three types of theorems present in the syllabus. That is, first is theorems which are based on angle properties of circle. Angle properties. Then theorems based on the cyclic quadrilateral. And the third part is tangent property of circles. So let us start with first the angle properties of circles. Angle properties first theorem is angle subtended by arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circumference. What does that mean? I'm drawing one circle. Suppose this is the center. So what the theorem says, just see the angle subtended by an arc. So now this if this is the circle, and suppose consider this part as the arc of the circle. So the angle subtended by an arc of the circle at the center. So this arc will make this angle at the center. Okay, this angle is double the angle subtended by it on any point on the remaining part of the circle. By this part of the arc, if it is making any part of the circle another angle, then this angle and this angle have some relation. That is, if this is x, this will be 2 times of x. That means if this circumference, this angle will be this angle will be 2 times of this. So the first theorem says that the angle subtended by any part, angle subtended by an arc at the center will be double the angle subtended by it at any part of the circumference. Okay. Next theorem says that angles subtended in the same segment of a circle are equal. Suppose this is a circle. Okay. So second theorem is angle in a same segment of a circle are equal. Now if we draw this diagram, see here, this angle, this AB is the, if we consider this part of the segment, ACB will be equals to ADB. These two angles will be angle in the same segment, isn't it? So angles in the same segment are equal. So here the angles in the same segment AB is ACB and ADB. So they are in the same segment of the circle, so they are equal. If this is x, then this will be x. Okay. Next theorem is angle in a semicircle is a right angle. So let us draw a circle. If this is the center, this is the diameter, and this becomes a semicircle. So this is one angle in the semicircle, and this is always 90 degree, that is right angle. So angle in a semicircle is right angle. So these were the angle properties of circle. The proofs are not there in the syllabus. Just only you need to know the theorem and their applications. You have to understand how you have to apply it in the sums. Okay. Next is the cyclic property. Now what is cyclic property of a quadrilateral, or what is a cyclic quadrilateral? If there is a circle and a quadrilateral is inscribed in it, then that quadrilateral is called cyclic quadrilateral. That means the points of the quadrilateral, the vertex of the quadrilateral should be in the circle circumference. Then that circle is called, that circle will be, this will be a cyclic quadrilateral. Okay. So first theorem states that, theorem 1, in cyclic quadrilateral, the opposite angles of a cyclic quadrilateral are supplementary. So opposite angles, that means suppose this is a circle with center O, and let us draw a quadrilateral whose vertex will be there in the circumference of the circle. It should be there in the circumference of the circle, all the 4 vertices. Then this is a cyclic quadrilateral. Okay. So now the theorem says that the first theorem is opposite angles of a quadrilateral are supplementary. If we consider this angle, its opposite angle is this one, they will be supplementary. Suppose if this is x and this is y, so x plus y should be 180 degree. Similarly this two, if whatever the angle is, measure of these two means sum of these two angles will be 180 degree. Okay. Next theorem is the exterior angle of a cyclic quadrilateral is equal to the interior opposite angles. What does that mean? You can go see the book. Actually the theorems are there in the book, so I'm just explaining the theorem part, not writing the theorems. The exterior angle of the cyclic quadrilateral, suppose this is the center, and let us first draw the cyclic quadrilateral. Suppose this will be the exterior angle, isn't it? Suppose this is A, B, C and D, and this is E. So this angle is the exterior angle. So what is the theorem is saying that the exterior angle of the quadrilateral is equal to the interior opposite angle. Now interior is this angle, if this is exterior, this angle will be interior. Interior opposite means this one. Okay, so interior opposite angle will be equal. Exterior CBE. What will be the theorem? What the theorem is saying that exterior angle CBE is equal to angle ADC. If this is the exterior angle, this will be the interior's opposite angle. It will be equal. Okay. Now if this is, you can easily relate that if this is the exterior angle, this is the exterior angle means its interior is this one. So this will be equal to opposite. Its opposite angle is this one. So like that you have to relate by seeing the sums. If you understand the theorems properly, it will be very easy for you to solve the sums. If you don't understand the theorem, then you won't be able to apply this on the sums. Now next we will see the tangent properties of circle. What is tangent? Tangent is nothing but if there is a circle with center this O, and if a line from exterior touches the circle at just one point, if an exterior line touches the circle at one point like this, then this point is called this line is called the tangent of the circle. Okay, then this point is the tangent point and this line is the tangent of the circle and this is the center O. Okay, so first theorem is the theorem which is given in the book. The first theorem states that the tangent at any point of a circle is perpendicular to the radius of the circle at the point of contact. So this is the circle with center O. The tangent at any point, this is the tangent at any point, is perpendicular to the radius. This is the radius from the center. If it is touching the circumference, that is called the radius. The point of contact of the tangent and the radius will be 90 degree. Okay, so what is the theorem stating? The tangent at any point of a circle, is perpendicular to the radius of the circle at the point of contact. Second theorem is theorem 2 states that if a tangent is drawn, tangent is drawn, before doing that theorem 2, let us know from an external point we can draw two tangents. We can draw only two tangents to a circle. So now if two tangents are drawn from an exterior point, then there are some things which you need to consider. That is, first is, this is the center, there are two tangents. The tangent's length will be equal. Suppose this is P, this is A and this is B. Then first thing we can tell about this is PA will be equals to PB. The length of two tangents will be equal. Second thing we can say that angles, that is a tangent subtend equal angles at the center of the circle. These are the two tangents and they subtend equal angles at the center. Okay, let us join this. The equal angle at the center, okay, means these two angles. So angle A, this is O, suppose AOP will be equals to BOP or POB, whatever, BOP. These two angles will be equal, and also this pair of angles will be also be equal. The tangents are equally inclined to the line joining the point. So when any tangent is drawn from external point, two tangents are drawn, then these are the things which we need to consider. The tangent length will be equal, center angles which the tangents are making, that will be equal, and also this, the tangents which are equally inclined to the line joining the point at the center of the circle, that those angles will be also equal. That means OPA or APO angle will be equals to BPO. Means these two angles will be equal. Okay, then the next theorem is, if two circles touch externally, suppose these are two circles with center this and this, if they touch each other externally, then the point of contact lies on the straight line through the center. This is the straight line through the center, and this is the point of contact. If we consider this is actually the common tangent. This line is the common tangent to both the circles. So this lies on the, if two circles touch each other externally, the point of contact lies on the straight line through the center. Next is, if two circles touch each other internally, then also like this. Let me draw the diagram. Suppose this is one circle and another circle, let us consider like this. Okay, if this is the center, this is the center, then also see, this is the point of contact. This is the common tangent to the both the circles. In this case, it is just if this is the center, this is the center line when produced, it meets the point of contact of the two circles. Now one more thing you should know, that is, in this case, if this one radius is r1 and here it is r2, then distance between this, suppose this is A and this is B, then distance between AB will be r1 plus r2, isn't it? And if this is A here and this is B, then see, this is the total radius of the bigger circle from center to this part, total. If that is r1 and if this is r2, then distance between A and B, this is A, this is B, just see it carefully, this point is A, this point is C, then distance between AB will be given by r1 minus r2, because this full radius is r1 and this small b from B to this is, suppose BP is r2, then this AB distance will be given by r1 minus r2. See, next theorem is, if two chords of a circle intersect internally or externally. Let us draw the diagram first, then you will understand this. Suppose there are two chords like this, one chord, this is another chord. Okay, now if they are intersecting, two chords are intersecting, here we can say that let us name the chords as this one is the one chord AB, and suppose another chord CD. AB and CD, if they are intersecting at the point P, this is the point of intersection. If two chords intersect, this you can see, as you can see from the diagram only, these two chords are AB and CD are intersecting at P internally, and if externally we will say like this. Suppose there is a chord AB and another chord CD. Now if we produce it, they will meet at a point P. AB produced to P and CD also produced to P, they will meet at the point P. Okay, so they are meeting externally in this diagram, and in this diagram they are meeting internally at P. Then the product of the length of their segments is equal. Then the product of the length of the segments is equal means PA. See, in this case, the segment is which one? PA into PB will be equal to PC into PD. PA into PB will be equal to PC into PD. In this portion, you can easily understand this is the one part segment. The chords are divided in two halves. PA into PB equals to PC into PD. And in this case also PA, this chord is only extended part, PA into PB, not AB. Just remember this from the external point, PA into PB equals to PC into PD. Never write AB and CD in this case. You just get confused, students get confused which part to be written in this form. PA is this full chord into PB. You just remember one thing, the part which is outside the circle, PB. PA full part into PB and PC into PD will be equal. This is one theorem. Another theorem is there. So another theorem is angle between a tangent and a chord through the point of contact is equal to an angle in the alternate segment. Now this diagram is very complicated, and also the theorem what is meant. If you don't understand the diagram, you won't be able to solve the sums. When you will see this kind of diagram, you will not be able to solve the sums. First you need to understand the diagram. So what is the theorem saying? Suppose consider a circle with center O. Okay, the angle between what they're saying, you can check it out from your book also. When you're seeing the video, just see the theorems from your book, then only you will understand. Just don't see the video, but see it from the book as well. The angle between a tangent and a chord. Suppose let us consider one chord. Okay, suppose this is AD. This is AD. The angle between the tangent. Let us draw one tangent here. Okay, so this is the tangent. Let us name the tangent as PQ. If this is the tangent and this is the chord, so it is making an angle. This tangent and this chord, they are making an angle, isn't it? The angle between a tangent and a chord through the point of contact is equal. Now which angle? This angle. This is the tangent, this is the chord, it is making an angle, this one. Now which it is equal to an angle in the alternate segment. Now this chord has two segments. This chord is dividing this full circle into two segments. This is the major segment, this part is the major segment, and this part is the minor segment, isn't it? So in the minor segment we are making an angle with the tangent and the chord, and suppose in this part also we are taking any point of contact, suppose C, then it is making an angle like this angle. So this angle will be equal to this angle in the alternate segment. This is one segment, this is another segment. So when the statement C, what is the theorem statement? The angle between a tangent and a chord. This is the angle between the tangent and the chord. Okay, this is the angle between the tangent and the chord through the point of contact is equal to the angle in the alternate segment. This chord is divided into two segments. This is another segment, so this point of contact, here it is making another alternate segment, another angle, isn't it? This is making another angle in the alternate segment, and these two angles will be equal. That means angle DAQ will be equals to angle ACD. Okay. Next, another pair of angle, we can say that, see, this is if this is the chord, AD is the chord, then this is one segment, this is another segment. So in this segment, if we consider this angle, then it is equal to this part. Now if we consider this angle, the angle DAP, this part, then this is the another segment. See, then here will be another angle, and this will be equal to this part. You just see one thing, that now see, I'm drawing a fresh diagram. If this is the chord, if this is the chord, see, I'm drawing a fresh diagram. If this is the chord and this is the tangent point of contact, it is making one angle this side and one angle this side. One angle in the this segment and one angle in the, this is the major segment, this is the minor segment. So major segment, minor segment. When we are considering the minor segment angle, then it will be equal to the angle produced here, this angle. And if we consider this part in the major segment angle, then in the alternate side we have to draw another angle, this one. This will be equal to this side. I hope it is clear. It's a bit confusing if you see the diagram, but it's very easy actually. Just remember that in the alternate segments, angles will be equal. Here this tangent and this chord is making two angles, one this side, one this side. If you're considering this side, then alternate side angle will be equal, and if this side, then this angle will be equal. I hope it is clear. Next theorem is, I can see it from the book. If a chord and a tangent intersect externally, then the product of the length of the segments of the chord is equal to the square of the length of tangent from the point of contact of the to the point of intersection. I'm drawing the diagram. All the theorems, you need to know the diagrams very well. Otherwise, you won't be able to crack the sum of the exercise. Okay. So if a chord and a tangent, suppose we are drawing a chord and suppose there is a tangent like this. See, here this is the chord. Suppose let us name this chord as AB. Chord AB and the tangent, suppose this is P and this is T. Chord AB and this is the tangent are intersecting at the point P. Then what the theorem is saying? If a chord and a tangent, see, if a chord and a tangent intersect externally, then the product of the length of the segment of the chord is equal to the square of the length of the tangent. So this is PA into PB. PA are the segments, length of the segments of the chord, isn't it? PA into PB will be equals to PT square. Square of the length of the tangent. Okay. So with this I cover up all the theorems of the syllabus, circles, which is there in class 10 ICSE. The theorems are not there in ICSE syllabus, so I am not just explaining full theorem, but I have explained the theorem, the statements of the theorem actually. So I hope you have understood the theorems and you can do the sums properly. Thank you.